like how RMS value will come from the thing. Whatever we will get in our multimeter, it's not an exact value.
Okay.
It is
an average value.
Yeah, average value. Yeah,
fine.
Like that.
Now forget about all that. I'm not going to the next step of what is called AC. I'm talking what is AC. Simple.
AC is a simple thing. Actually, it alternates with some frequency. For example, it will reach to some specified voltage.
Can you tell me the AC specification? What we receive over here?
Yeah, 220 volts, 50 hertz. It will vary in the 50 hertz.
Okay. Yes. Okay. What do you understand by that? What do you understand by that?
The thing is, it will vary with the 230.
This is only boom stuff. Okay. Something else is pretty good.
It's an amplitude of 230 volt which varies with the 50 hertz of its frequency is 50 hertz.
Okay.
Rate of change of voltage.
Yeah, it means 50 hertz.
Rate of change of voltage with respect to time is called as alternating current. Okay. The question is, how do you do something called measurement of AC, measurement of DC? DC is a direct current.
Yeah.
How do you represent DC? Can anyone represent DC over there?
Yes. Again.
No, go ahead, go ahead.
Go.
What is this? I sure is it DC?
Yeah.
There's no time, there's no voltage factor, nothing. There's no amplitude level. Thank you. Now this is DC. Now the other format is AC. How do you measure it? This, the measurement of AC and DC is explained in 200 pages. Simple. Okay? How do you measure AC? How do you measure DC? Is explained in those minutes. I'm leaving it to you. Options, I'm just leaving all this open for you.
Please.
In that, when we come of measurements, then you have something called series measurement, you have something called as shunt measurement, you have something called as combination of all this. Then you have all laws from some like KVL, KCL, your Thevenin's theorem, Norton theorems, your network analysis, signal, everything comes into it.
You can measure the excitation of coils.
Yes, you can do all this provided you understand this. Okay, so what are the kinds of losses? All things come into these two chapters, something called as an DC voltage measurement, AC voltage measurement. Okay? Then what is something called as current, what is something called as voltage, what is something called as Wheatstone bridge, what do you use Wheatstone bridge, what is full Wheatstone bridge, what is half Wheatstone bridge, right? What is junction current, what is potential. You'll be brushing across all this. Can you just go up? Now, what do you understand by single ended? What do you understand by differential?
Differential ended is measuring a voltage difference between two potential. Single ended means I will measure a potential difference with respect to ground.
Okay. Here, so it is 0 to 10 also. Single ended or differential?
Single.
Minus 10 to 10 also. Simple example. Yeah. Okay. Next. The fifth chapter over here is fundamentals of signal conditioning. Now, whatever points I mentioned for signal conditioning, right from the stage of amplification, right from the stage of filtering, right from the stage of processing all this data, we have all this. When is isolation required? When is an attenuation required? When is all these factors which are required, and as something called as signal conditioning. Okay. Can you go to the next? In that, again, there is various three forms based on resistance, based on capacitance, based on inductance. What is now from here onwards? There will be an in detail technical specifications like what exactly is an RTD, what exactly is your thermocouple, what exactly is your temperature sensor. Now, how are they going to differ with respect to the parameters? How they are sending their signals. I said you have a resistive form, They are capacitive form. Okay. The various temperature sensors which are available. Now we should be in a position to tell why should I use a thermocouple for a given application? Why should I use an RTD for a given application? I'll show you with images, with videos, I'll show you all this live code. How does a thermocouple look? Because I'm sure many of you have not even seen what is an RTD, what is a thermocouple. And if I take a thermocouple categories, you have many categories, right from J, K, L, M, N. There are many categories of thermocouples in which various are used for various applications. Correct? Next we have something called as, this is what I said, stress measurement and strain measurement. Now how do we do analysis of all this? What are the sensors we are going to use over that? And how do we take data from that? And which are the applications in which we do stress analysis, strain analysis? Is this an application for it?
Yeah.
How?
But how much of stress it can take when you put something on it, or what is the amount of?
This can go up and down, right?
Yeah.
They have calculated what is the maximum stress or maximum strain that it can take. All this could be done with those kind of sensors. Next, you have something called as vibration and so on. If you look this whole chapters and units, each one of them are nothing but your lab view toolkits. You have the dedicated toolkits for these dedicated hardware signals. Okay? Now, at the end of the sessions, we will be thorough like what is the data acquisition we are doing, what are the kind of sensors we are doing, what are the software we are using, how we combine everything to finish the end-to-end process. We'll be well-versing with all this step-by-step activity. Okay? So I'll be taking it parallelly. When it comes to hardware, we're going to do physically over here. Okay? How do you analyze all this? You have something called as displacement sensor, you have something called as cohesion sensor. And I told you have various kind of motors. Which one you should opt for something called cohesion, which one you are supposed to opt for which is something called as not only motors, even there are various form of sensors. Why sound comes into picture, why light comes into picture, what is the resolution of it, how do you take it, what are the forms of signals you get, what is the kind of signal conditioning you are supposed to do there, and how do you take it from there to your data acquisition. Right? Then we have 10 chapters, something called as noise reduction and isolation. What happens if a particular wire is not used? If the gauge or the thickness of a wire is differed, how does it affect? How does it, if there are leaks, how does it give an introduction to something called noises? How do you eliminate noises? What is type of insulations you are supposed to use? How do you define all these parameters? Because you can just, on a crude way, you can just do it. I connected and I just took wire and did it. But what's happening internally? Where are the noises getting induced? How does it disturb me? How do we isolate that? How do we shield that? How do we protect that? And how do we still manage to get an effective data out of it? Right? There is a chapter which will be dealing with. Let's go to next. This is what we are discussing, right? A few minutes ago, you told your basic 80-51 was not able for the application what I mentioned. And end of the day, we said it's possible, right? Now, how do we do all this? Okay? Just go to next. The last one is transducer electronic data sheet. What are the key aspects or importance of a data sheet? What are the important parameters that you are supposed to look into a data sheet for you to build an application with a given respective sensor or a data acquisition? These are the chapters in which we cover. We are at least going to get some gyan for something called as data acquisition, and you're going to applicate. You're going to understand how exactly an application or a unit or a system works. Right? So on the first session, I just introduced you to the number of chapters, what we have over here. What are the? I'm sure on a null sheet you would have understood what is sensor, signal conditioning, data acquisition. Various means and forms and how it has been engineered and all, we'll go through one by one. So the next session on this class will be questionnaire. Very clear? Questionnaire. I gave you 3 questions already, and you will have a general questionnaire for this, wherein which we'll be understanding each of this. We're not expecting an in-detailed answers for all of these, but as said, you should be aware with respect to applications. If I give you an application, you should be tell me an end-to-end, definitions of how this application is going to work. Right from a simple motor, just like an XY stage control, what type of controls, what is the everything. Okay, we just go through this book. I already circulated to all people. So the next session we'll go with questionnaire. From there onwards, we'll carry on with each of the units with live hardware, hands-on experience.
One request. Please start with the thermocouples.
Sure.
Because
I'll give you the various classification of sensors. In that, we will have a data acquisition unit. We'll try to measure, and we're gonna perform the experiment hands-on. Okay. Any questions from your end? Is this session interesting? Is it useful for your video applications? Yeah? Okay. Thank you. We discuss now. Yeah?
thanks.
Please.
When are we going to see the baby?
That's going to be after 20th of December. Yeah. Because she's not supposed to travel now for the next 1.5 months. And after that, it's only the. Kalyani can't travel. She's not supposed to travel for the next 1.5 months. So, because that is going to be only in December.
Can we go and see her?
But you're all, you're all welcome anytime. Mumbai, anybody, any plans coming around Mumbai, let me know. You can drop in anytime. That's no issue.
And when is the party gonna happen?
Yes, you tell me.
You tell us.
Right now it's only a few very small sweets and all that just for Bhumika stuff. But yeah, you tell me. Decide. Floor is open to you. Tell me where, when, and we have it.
We'll make a big group plan.
Oh my god, the word big itself was stupid.
Well, we have that big plan in the baby.
Sure.
That's it.
I can't see you.
This was within the first 20 minutes.
Binary numbers are already
10
petty.
words.
Oh my god.
Transfer.
Crazy. That's what I heard when Arun was mentioning. Then he called me sometime and he heard baby crying. I said, oh my god, already the frequencies are out.
What do you want to discuss now?
We all, no one got the attachment. We just got
I just, on a very urgent basis,
I didn't send it out, right? Finally, instead of you asking for it, I didn't send anybody anything, right? It was Kalyani again at the end of the day who sent it.
So, moral of the story is to get your requirements done, please ask appropriate questions.